Oh, hello, and welcome back once again. Great to see you guys all out in chat. I see a lot of new people, a lot of hellos. Joseph, how's it going? 6040 CNC, that's awesome. Outside of that, we also got Mateus. I apologize, guys. A lot of these names get me going good. Elijah, it looks like. Ogden's here. Awesome. Great to see all you guys. Welcome back to another Fusion Friday. And it's not a Fusion Friday anymore, right? It's Free Support Friday. But it has been quite the week for me. I hope that each and every one of you guys all have had a way better week, not as hectic as myself. I actually last minute flew to Vegas. But we'll give this a couple of minutes before we dive into a couple of things. As always, guys, if you guys have any questions at any time, feel free to throw them up in the chat. You can also use a support email down below to go ahead and reach out to us for content you would like to see and share your files while we're live, or outside of that, anytime you guys might need help. So, as always, we are going to kick this off. I do have a Buy Me a Beer program. It seems you guys always get a kick out of it. I've already started on this energy drink because it's been quite a wild Friday on my end, but I want to thank you guys for your support as well. So, let's go ahead and dive into this. I'm going to get my screen up. I assume you guys can all see me. JC, great to see you out there. So I actually had this one sent in super late last night, and very interesting part, right? So what's happening is they have some dovetail locations on a part. I know some of you may or may not know how to do dovetails, but the key element is a multi-step down, create that dovetail inside of this part. Now, they've already roughed this out. They've already done some work on this part, as you guys can see. So the very first thing we all thought about going to is, well, hold on here. Finishing vertical walls, plunge milling style. Can it be done? Ogden, it can be to some extent, but I would have to see what you're looking to do, right? So are you plunge milling style? So plunge milling around the outside of that wall, or you just want to plunge down and go around? So that being said, I'm going to go ahead and get back to this. So let's kick this off. So the first thing I recommended that he try is actually a 2D contour. And he is using a plotting saw for this. But my idea is we were going to go in and we were going to do one side, of course, just to make this work. And then for you guys that don't know, is in multiple depths, you actually have a tapered wall angle. Now, as you can see, this is an overcut feature. So again, we're having to undercut when we go down that wall. So one of the things is, we went in, and if you say 15, you can't do a negative 15 situation. So this is kind of one of those things that makes a night and day difference when you're trying to do step downs on features like this. So the next thing I kind of thought to myself is, well, what happens if we were to use, a 3D toolpath? So in this case, some of you guys may or may not know this. I found this out the hard way a lot of years ago. But if you do something like this with 3D contour instead, I'm going to go ahead and pull up the geometry tab. And we're going to give this a silhouette boundary. And then from that, I'm going to keep the tool on center. And I'm actually just going to hit OK. Now, as you can see, again, because we're using a 3D contour, what's happening is it is allowing undercutting based on the relief of this tool. Now, keep in mind, anybody that's ever took training from me, we always say you want to now filter in Z to get the blue lines down a little further. So what I'm going to do is we're going to jump back to our heights tab, change our top height, and grab that upper edge. So I see a lot of you guys talking in chat. We'll jump over there in a minute. And then lastly, as you can see, this actually worked out quite well. Obviously, customer needed to adjust step down and step over. But I would like to keep the tool at a minimum retraction. As you can see, that tool is retracting all the time. Again, using those yellow lines, I can go to my linking tab and make those changes. But as you can see very quickly now, we're going in, we're using that T-slot cutter to cut our dovetails on our part, and we've constrained it to that area with the few mouse clicks as possible. So let's see what you guys got going on in chat. So just bought a brand new Herco. Hope inspection works pretty well. It does. It actually works extremely well on your Herco, but make sure when you're in the post, there's a lot of things that you have to set, like certain variables that it needs to pull your actual probe calibration data. So Bogdan says tool cuts in Z direction instead of XY. Bogdan, do you have an example or something you could send me? I'd be happy to take a look at it. I assume you want to go up and down a wall versus laterally across the wall kind of thing, correct? Awesome. So again, kicking this off real early. We have a ton of people starting to come in to see this video and all that. We just started off by doing something like an undercut of a dovetail using a T-slot cutter, as was submitted to me before. Now, I am going to jump over. I don't know, Ash Designs, are you out there right now? He actually sent me in a pretty interesting part, and he was having a hard time with getting chatter in this part. He was the one that asked last week about, hey, is there a good way to approach chatter on parts like this, right? So I'm going to go ahead and pivot over. Let's go ahead and start by creating our setup. Now, for a lot of you out there, what I'm going to do is I'm going to start with what was provided to me, and then we can go back and take a look at a few other things, right? So again, we have our XYZ. We need our model here. And let's go ahead and grab, we don't want our fixture. We want that master model. Our stock is going to be from Solid. As you can see, he has stock here. And then lastly, I am going to add the fixture in just for collision detection and things like that. So as you can see, we now have our setup created. I can go in and start creating my toolpaths. Now, we talked about something like this last week where if you were to, for example, 3D adaptive clearing, let's see what kind of tools we have to work with. So let's go with our 1/2-inch flat. Again, I am going to have to modify this tool, but we're going to start with a Z orientation over here to the right. And then we're going to let that do its thing. And then we're going to come back and make some changes to it. So in the meantime, we can let that go. Obviously, it's going to take a second to calculate. I will have to fix this tool, but I think we're going to get a pretty good result. And then from that, we may have to make quite a bit of changes, right? Because his problem is as he's machining something like this, is he is going to start to get chatter because this part is so large or so tall at the end of the day. Again, pretty crazy retraction policy. I've seen this a lot. Now, the reason why we're seeing so much retraction is because Fusion is retracting to clear the top of the jig and the fixture. So this is one of those things that I tell a lot of people is you do not actually need to model your table because your table is going to be set up in your machine sim, right? So let's fix that right off the start. So I'm going to go ahead and check out his fixture. So he's got his tie downs here. He's got his 5th axis vise. And then what we're not going to do is grab the table this time through. And then I'm going to go ahead and double check my heights on this toolpath. Now, normally I would tell you guys to go ahead and just hit, regenerate the toolpath. But as you can see, the reason why that was happening is because we have a fixture top in our retraction policy, right? That's why we were so high to start with. So I'm not changing anything. I just wanted to show you guys where that was, because now when this toolpath recalculates, you're going to notice that it actually stays much closer to the part, and we're probably still going to get a retraction to the highest point of the fixture over here, right? So again, while that calculates, we could actually do quite a few other things inside of Fusion 360, which is nice. I may want to machine back the other way, so we're going to go ahead and duplicate this. I'm going to go in, flip my Z axis. Again, because my lovely rest machining that Autodesk has given us is we're only going to find the things going back the other way. Now, some of you are probably starting to realize that we are getting down inside of that part. As well, because of our tool, we would have collisions of our tool against our fixture. But the idea is I wanted to get some paths on this part real quick for you guys so that you could start to make some suggestions or ideas on how we could limit where our tool path goes, right? So if any of you guys have ever caught any of my content out there, is I would start on this part, I think I'm not going to want to machine anything down here at the base. But I think because of the way he was talking and the results he was getting is we might actually kind of layer down this part little by little and start at the top and do as much finishing as possible before going to the next layer below. So what I can do now is I could actually go back to my design workspace. Again, I could get that stock turned off, or you guys could leave it on. I'm actually going to use the stock face for my sketching here. And then from that, I can go ahead and create basically rectangles of area for working, right? So let's say I only want to go down this far in my first segment, maybe this far in my second, and then lastly, I only want to finish down to about here. Now, with that being said, is I'm going to add another window here, which will probably confuse some of you. But the neat thing about this is we can use these sketched rectangles that I have to limit where and how my toolpath interacts, right? So if I jump back to manufacture, I'm going to go into that first roughing. And what I'm going to do is I am actually going to give this a machining boundary, right? And that's going to be my big rectangle. From there, I'm going to go ahead and keep the tool always inside of that rectangle. Now, from stock side of things is I actually have the ability to do a selection for stock versus a silhouette, right? And because I created those rectangles off my initial tool or my initial stock size, you can see how easy it is for me to grab just one of those yellow areas, right? So now I know we're going to get a little bit of a funky mess here because it's going to think that it can work down here at the bottom, of course. Now that would be where I may need to make more rectangles around the outside of my part, limiting where it can and cannot go. And this is what I was worried about. As you can see, we would be plunging in here, causing some problems here. So again, I may need to change how that rectangle interacts with my part. Again, you can make multiple sets of rectangles as you work down that part. Now, what I'm going to do is we're going to go ahead and edit that sketch down here. Let's go ahead and throw in our horizontal vertical, of course. And what I did there is I just made sure those two rectangles sit nicely amongst one another. We jump back to manufacture, and I'm going to use a hotkey here, Control G, to regenerate that toolpath. And now, as you guys will notice, is we are starting outside and working in. Again, the idea here is if somebody could turn on their stock representation of this part, notice how I've only worked my way so far down and roughed out just a small segment of it. So if I wanted to now, I could start to finish up more of this part. And again, going for rigidity, going for stabilizing it, keeping it as much material there as I work down. So from here, I'm actually going to change up my complete system because I think there's going to be a better way. And I'm surprised none of you guys have said anything. Bogdan has submitted a file. So let me go ahead and pull up another window here and see where he sent it. So looks like you actually used the support link. Let's go. Makes it much easier on me. So we're going to go ahead and open this up. Give me a sec to get this file downloaded real quick. And of course, we need to upload that. So let's go ahead and throw that in there. And we're going to go ahead and let that load. Oh, loaded pretty quick. So we can always come back to this part to work more. Again, guys, if you guys have questions at any time, I see quite a bit of you guys jumping in and out here. So I'm going to go ahead and I need to clear out a few things. There we go. Alrighty. So you should have just told me you were machining a rectangle, right? All right. I see what you're trying to do here. So what it looks like he did is he did a trace toolpath. So he's plunging down and then retracting back. And then he wants to do that the whole length of the part. Yes, you can. 100% Elijah. You can submit a part at any time. There is a email address down in the bio of this video. I believe Bogdan might be well enough. He could go ahead and copy and paste that in chat so you can grab it and send a file over. So what Bogdan's wanting to do is he was wanting to basically plunge down along this surface so that he could generate and machine that part out. Now, there's a lot of reasons why you may or may not want to do this. And right off the top of my head, I think he's actually got a pretty good system here. Now, the question I would ask for him is, does he need to get to the bottom and retract back before retracting back up? Because one thing that might actually work here, you're on a personal license, so you can't do that. Can't do what is that? I'll go ahead and give you a second. So I'm going to jump over to a parallel toolpath. Now, a parallel toolpath, some of you guys may or may not know. Oh, share a file. No, Bogdan, I was saying when you emailed in to create a ticket, there's a email address that you used. Can you put that in chat for me? Now, what I'm going to do with the parallel toolpath is one, I always tell people, let's go ahead and hit OK and see what we get right off the start, right? So one thing we are getting is we are getting a straight line toolpath. We are just getting it across the top of our part, right? So if I need to extend how this toolpath works is if I go in and I look at my geometry, and the reason why I'm looking at geometry for you guys is, let me go ahead and close this window here, get flipped up, and we're going to get our stock turned off. So as you can see looking down, is my toolpath does not extend past my part, right? So that would tell me in XY that I need to change something. So let's go ahead and say tool outside of boundary. Let's go ahead and hit OK again. And now as you're seeing is I'm actually getting that toolpath to come up these faces as he's kind of requesting, right? Now, big problem is I'm going, of course, all the way over the top and then back down the other side. However, I could start to use this for my advantage. So the first thing I might want to try is this lovely avoid touch surface, right? So I'm going to add in an avoided surface, which is going to be right here. And we are going to go ahead and say radial or axial. Let's go ahead and plug in 10 millimeters because I don't know the difference between inch and metric off the top of my head. And as you guys are noticing, I now got an empty toolpath. So it did not like the idea of forcing that actual toolpath to avoid that surface. So a few other things we could also look at on this particular toolpath is also using that sketch method for a boundary, right? So what I'm going to do is I'm going to go ahead and jump back to design. We're going to create a sketch on that top face. And then what I'm going to do is I'm going to drop a rectangle coming outwards. Again, we're going to use horizontal vertical. I would like to just line up the lower corner. And as you can see, I now have my rectangle for my toolpath containment. So again, we could go back to manufacture. We could try this one more time. So instead of a silhouette, we're going to select our boundary. And again, we're going to hit OK and see what we get. So again, we're slowly creeping this tool down to be strictly within a certain area. Now, one thing I haven't shown and one thing I am afraid of that might happen is we might get to a point because this surface, when you think about it, is 0, right? So it is vertical right on that sketched edge where we put everything. But let's go ahead and reduce this now. So again, we're going to now change for tool center on boundary. We're going to hit OK again. Now you can see we are coming out and away from that part. Again, still staying very vertical, right? So if we go one more time, and I think this is where we're going to start to get into trouble, is we're now going to bring it to stay all the way inside the boundary. However, we may have got lucky here more than we've ever imagined. However, we're lacking that left and right lateral limit, as you guys may or may not know. So now there could be some other things we could do here. One being is we can extend that rectangle left and right to get more room. We could also try again is let's go back, and in this time we could say tool center on boundary, contact point boundary, and see what we get. Now this is where I was thinking we were going to get a problem. And the reason is contact point boundary at the end of the day is designed to work where we shift from center line of tool to center line of wherever that radius of our tool is engaging, right? So a way we might be able to get around that is saying tool outside of boundary again, slowly opening up to see what we can and cannot get with that toolpath. So again, tool outside boundary seems to work with contact point boundary, but we can again go back, try center, of course, and then at center, we're getting that error. So there's a couple things we can do. Again, you have so much limitation in how you do this geometry and where we define everything is sometimes by plugging in a very simple additional offset can also affect, as you're seeing, is now it's allowing that tool to go 2 millimeters past and create a whole nother scenario outside of what we were wanting. But I'm going to go ahead and undo this because I think I got a little bit too far down the rabbit hole and might have left or actually caused some of you guys to get confused. So let's go back, close chain, tool center, zero this back out. And of course, we're going to leave contact point boundary on. So one thing I can now do here, though, is when I always teach these classes, I love teaching you guys on this Fusion stuff, is we've basically filtered our toolpath down as best we could in XY. So now we can look at filtering something in Z, right? So again, I go back to my parallel toolpath. If there is a radius on your cutter, looks like the tool disappeared here, is I might actually want to, instead of starting from, say, your stock top, we could go model top and then minus whatever that radius of the cutter is. Again, apologize for all my bald eagle friends out there, but by subtracting that 2 millimeters, again, I don't know what that radius is off the top of my head. As you're seeing is I'm now getting a plunge profile, but it's also starting to segment and break things up. So again, there's a lot of ways to start to manipulate a toolpath, which we should probably start by yours truly getting So it is a 2mm, a 20 R2. So I'm assuming that's a radius of 2mm. So again, is sometimes by changing that to a little bit smaller than what that radius is. So we're going to say minus 1.9. I've gotten back my entire toolpath as I wanted. It does not look like we're actually waterfalling over the left as well. But again, very simple, very straightforward. Probably not the best of straightforward. We were able to get that plunge toolpath using 3D to work as you saw him doing basically with that trace pattern. Now, in the case of this part, I think we're going to luck out where we could take our toolpath now and do a new pattern. We're going to go circular. What I'm going to do is I need a center axis. So I'm able to use the origin on this part and then up the ante to 4 times around. And again, I don't think there's a right or wrong here. I think there was a lot of good things happening as you saw originally with what Bogdan was doing. Bogdan, you're going to have to let us know. Does this seem like something that might actually work for what you're doing? Again, I do know we could reverse the direction. So we start at the top versus going to the bottom. So can you make it so it only cuts down? So we should be able to. Let's go ahead and take a look at our parallel toolpath. I think by default it is set to both ways. Now we could say one way, the other way. We could also say only down milling. And with only down milling, as you're seeing, we're going down, we're looping out, and then we're coming back up across the top. Now this is a little messy. So for you guys at home, let's go ahead and change our step over to something much larger so we can see. So again, now you're coming down with a feed rate, you're leading out, and you're rapiding back up. Again, continuing down that part as you can see. Looks like, let's see. All right, let's scroll back up here real quick. Elijah, it looks like you sent a art file and Deep Thinker post question. Challenge for me. How do I get the post to ignore a coolant air blast as it is used in different machines and don't want to change the tool path when changing? So that is something that there's a couple ways I can think about what you're trying to do, but I think I'm trying to think off the top of my head the best way to show what you're saying. We'll actually stay with this part, right? So let's get this sketch out of the way so we don't get too confused. Now, the problem he is saying is some of his tooling may use actually an air blast. He might use through coolant. He might use like flood coolant, right? Every machine is a little bit different. But if I was to machine on this part here, I'm just going to do a simple 2D contour, right? Because we need a tool path. So if I edit this tool, what we're going to look at first is we want to know what kind of coolant this tool is using, right? So when setting up your speeds and feeds on your tool, you have the ability to select what it is that it uses, right? So this would be the first part where, as his case, he was talking about air blast. He may actually set it to air, or he may say, you know, flood and through air. With that being said, when he goes out and he actually post-processes this, so I'm going to try my best to make an accident happen here, and I don't know if it's going to happen. Of course, it's going to post out properly, and then it looks like, are we going to get a coolant M8, M7 coolant codes called out, right? So in the case of this post, it's already there. What I would recommend is the easiest way to edit a post processor is to actually go in and click your pencil here. You do always want to have the, where is it here? The Autodesk Fusion post utility installed, of course. And then I am going to just create a real quick debug file. What we're going to say is milling in this case. I'm assuming he just put a message in chat that said something about it being a lathe or a shop machining issue, no air blast in Haas. Yep. So again, what I got here is I got my debug code. Now I'm looking for my coolant code, right? So as you can see, there is a set coolant, cool.coolant. Again, we could go ahead and control F some of this stuff. And what we're looking for is the ability to set up that exact call out, right? So again, as you go through, you're seeing that function set coolant, and then it's calling some code. So it's not quite giving me the tool.coolant code that I'm looking for. So again, we could control F that. You do have tool.coolant. Again, down here a little further, there's an area to put a coolant code in. And it looks like yours truly is going to have to look at this one more way. So let's go ahead and go to M8. And then let's click it again. But what we're really looking for is, there it is, coolant codes, right? So this is where it's going to get a little tricky because you have a variable for coolant code, and that is get coolant code coolant, right? So we need to find where that code is getting called out. Now, here's the real quick trick. If you guys didn't know, if we actually search something like mformat.format, and then what we're going to do is we're going to place the number 8 inside. Now, that didn't work, of course. But we could also say something like 08 or just 8, because at some point you're going to find where that coolant is called out. Now, I will say things like words that you know, like flood coolant, through coolant, things like that. This was the segment I'm kind of looking for, right? So what's happening is he has the codes here. What we need to do is when it's creating that coolant call out, you basically need to do an if statement, right? So on that specific host machine, he could put if coolant is through coolant or flood plus through coolant, he then could force a different cool code versus the error he's getting. I'm not going to dive really deeply into it because I've had a very rough week. And I would say Deep Thinker, yeah, 360, yeah, 100%. So 30, I think you're looking at a different post. That's the smoothing here. But 100%, as you're seeing, is the ability on this post in particular. We actually have multi-line coolant. So when he calls out the flood and the actual through air, it spits out 2 separate lines on that post processor. So again, that ability to edit and do an if statement would take care of that. So let's go ahead and go back. I'm going to go ahead and jump over to Elijah. Looks like Elijah sent in a ticket. Let me get this one resolved here real quick and out of the way. Wondering if I can mill this out of steel with a double radius cutter on my mill. Let's see what we got. So I'm going to go again and we're going to re-upload that part. Deep Thinker, if you want to see more on that, I'm more than happy. Put in a ticket and we can reevaluate and see what it's going to take to do that on my end. Let's see here. I'm going to go ahead and clean out some of these emails since you guys are starting to put in more parts and make this, of course, more interesting as always. There we go. And here we go. And that should be the pulley, right? Give me a sec here, guys. Let's get all set back up. There we go. All right. So the question is he wants to mill, I'm assuming this V-pulley, as he states. So let's get your ticket pulled back up here. So he wants to use a double radius seat cutter on your mill. And let's see here. Okay. So real quick, I got to get my chat pulled up just because I was reviewing everything in my brain. So Elijah, you want to mill this starting flat, I assume, right? So you want something like this. And then you want to mill the V-cut or the belt drive or whatever we're going to call this with a T-slot cutter, correct? I'll give you a second to answer in chat. Let me double check all this. What type of toolpath would you use for a dovetail groove with a radius in the bottom on the... Can you, JC, can you send me a part also to that link? Okay, cool. So again, as we kind of saw already, the big problem is going to be on a part like this is I'm going to jump real quickly to just 3D contour, right? So here's my 3D contour. I'm going to go out and select my tool. In this case, might actually get lucky. Go ahead and copy this tool from that other part we just. So again, we're going to paste that in. And then I'm going to edit this tool because as he's saying, there is a corner radius of something. Now, guys, I understand yours may be different. The dimensions might be different as well. We're going to need like 3 millimeters with a... All I'm looking for is a T-slot cutter with a radius, right? So by default, again, as I always tell people, let's go ahead and hit OK first and see what we get. So again, what we got is a no passes to link. And usually what that tells me is I like to start in the XY world. Again, if the tool's on center of this part, because of silhouette, we can't really achieve what we want. So let's go with tool outside for a quick first iteration change and hit OK. Now, what I think he's going to notice is right off the start is we are now getting that T-slot cutter in and around our profile, right? So as you can see, again, using 3D contour can do quite a bit with some simpler settings, especially when causing undercut scenarios. Now, I assume my tool is very large. Actually, that's center line of that process, but it is getting down underneath that area. Now, the real problem will be is only doing the outside area, right? So if you're one of the lucky individuals to have the machining extension, easiest way to do this would be to say, I'm just going to trim around this part, and I'm going to keep that tool path that is on the outside of that profile, right? As you guys can see, I just went in and I quickly trimmed that area so that I could easily stick to just the outside profile, right? Now, if I undo this and bring that back, I could also do the same thing temporarily with sketches. Now, again, trim toolpath, amazing feature. However, we got lucky on a pretty simple profile here. So if we go back to design, dropping that sketch on the top surface, and again, all I'm looking for is basically creating a boundary or a set of boundaries, right? So again, we go back to manufacture. This time, instead of using a silhouette, I'm going to use selection. Again, I can pick my inside edge and my outside edge. And as you're going to see here is we're now only machining between those two edges using a sketch to my advantage, right? So again, get that sketch out of the way so you guys can see and how that tool path is wrapping down and around. So you do have the extension. Awesome. Did you buy that extension from me? If not, you should have, right? But again, that pretty straightforward. You guys in your undercutting today is cracking me up. But based on how you guys do it, obviously what you're seeing is we actually are ramping down each layer and then going around just an XY. If we were to go in and derive this, meaning we're going to force now a ramp toolpath with the same settings. But you can or cannot notice is I think it's going to freak out a little bit, but ramp also has the ability to do undercutting automatically. So with that undercut, as you guys can see, it is going to actually consistently go down in Z and spiral using that Z axis as well versus an XY only kind of toolpath. So your grandfathered in, technically no, don't worry about it too much. You could always just buy me some beers instead down below. So let's go ahead and see what other stuff we got. JC, did you send in a part file for what you were asking for? I'm going to go ahead and check the good old support area. You guys are lively today. I love it. You're getting me going because I'm going to be going until probably like 8, 9 o'clock tonight. We'll go ahead and let JC send that over. Jack in the shop would like to create a pocket in the middle of my material. Is there a way to make the pocket in random circular patterns with a 1/4 inch ball nose with a large step over to make it look like hand carved? So you want to kind of like the way I think about what you just explained, Jack, is like an ice cream kind of scooper profile is what you're looking to do. Adrian, great to see you out there. So Jack, I'll go ahead and give you a second. JC, if you have a part file, feel free to send it in. Oh, okay. So you want kind of like an ice cream scooper profile in a pocket. So one thing I would tell you, I'm assuming, yeah, let's go ahead and draw something up here real quick. So the real problem I foresee, and somebody out there might be able to say something a little better, but in a lot of other softwares, you have the ability to create a textured mesh. So I would ask you how much of a pattern you want it to be, or how would you like it to look? Do you want it to be randomized or do you want it to be a pattern, right? Because the first thing I could think of off the top of my head, so if I go ahead and create this profile, right? And then I'm going to go to the form tool. And now what the form tool will allow me to do is actually to change things up quite a bit. So what I'm going to do is I'm going to create a new sketch here. I'm just going to do this kind of like a bowl if you guys are wondering. And then I can create a plane using that actual sketch. Look, give me one sec here. At least I thought I could. been a minute since I've had to use the, yeah, we're going to have to do this a little bit different ways. So again, we could actually do a cylinder here, and that's not going to give us the end caps that we need. So what I'm looking to do, and I think I'll just do it the random way here, is if you want it to go for more of a random texture, what I'm doing is I'm creating kind of that mesh in the background for me to manipulate, right? So with that, I can then use the edit form function and create and manipulate those surfaces to whatever I need them to be, right? So I'm going to do this just a couple of times. Again, we're going to go ahead and say I want to bring this one up. Now, it's not going to be a perfect scenario as you may be thinking, but what it is, again, trying to do and give me is a surface to work off of. So now that I have that surface versus my solid, and you guys will see that still in the background, I could possibly cut one using the other, right? So again, we're going to say split body. I'm going to go ahead and use that as my splitting tool. Oh, go ahead and start over. We need to split that body using this tool. And it looks like we're getting an error because that surface is small. So I am going to pivot here real quick to machining kind of this surface to, again, show you that it's going to follow that profile, right? So it's going to take a little bit to give it that hand-carved kind of shape and profile. But if we threw at this, again, I'm just going to go for a scallop toolpath. And I think I have a 1/2-inch ball in here somewhere. There we go. And then beautiful. So again, I think we'll see this more once we see the toolpath. Again, I don't have my stock covering that whole surface, but the idea is to follow what would be considered the zebra analysis. If you guys didn't know, there is what's called a zebra analysis inside of Fusion. And what this shows you is the actual kind of lines and the layers and the bends and the shapes of what you have. So Elijah, thank you very much for the beer. I appreciate it. A Sierra Nevada, very awesome. Great to see you with the actual chat. So the other way, I mean, a few other ways I could think about it is you're not going to get a random pattern because everything in Fusion is more built around that like perfect kind of surfacing. So again, even if you did something like morph spiral, it's still going to be, you know, a spiral. It's going to be, in the world of parallel, you can do it bi-directional, but the thing still has the same problem at the end of the day. Is it's going to be like a checkerboard, right? It doesn't give you that random factor. I would almost tell you it's easier to go off and use something like Blender or Rhino to create that texture and then bring in that texture map inside of Fusion. So, JC, did you ever send in a part? I would hate to leave you out there. I'm going to check again real quick. I don't see anything in my ticket system, and I don't see any emails. Does anybody else have any other questions? Get chat pulled back up. Here, I gotta scroll up a ways. You guys are getting pretty wild out there. You need to check on one other thing. I have a surprise for you guys. I don't know if it's gonna get released today, and we're gonna start doing things with it. Yep, not quite. So we're gonna go ahead and close that out. We're gonna save that for a little bit later. So let's go ahead. In the meantime, if you guys do have any questions, feel free to throw them in down below. I'm gonna go back to this bracket that we were working on, right? So now, in my opinion, on a bracket like this, I would actually reposition how it is in my vise or how it is that I plan to machine it, right? So I'm going to jump back to design. Good thing about this lovely timeline down here is I can actually yank out of it everything that I did. Now, I did not design this, so we're going to have to take a look at how everything is stuck together. So it looks like we have a couple of joints down here at the bottom. There we go. We went ahead and deleted those. Looks like we have a couple breaks in our part. Let's see what other joints we have going on. So we're going to actually back that up one more time. We need to see how this was built. Got a rigid. That's stuck to the table. That's to the vise. That's to the vise. That is a rigid group that I think is going to cause us some problems. And then lastly, okay. So let's get rid of this rigid group to start. And I think we can get rid of these two. Oh, not quite. So again, we still have another rigid group here. There we go. We had to break this vise a little bit, as you guys saw. And the reason is I needed to remove some of those joints out of my part so that I can efficiently get the part away, the stock away from everything that's going on. So I'm also going to remove that other joint, placing my part separate from my stock. Now, he did cut a dovetail on here. Not a bad way to do it. As I've decided is I think what I would do at the end of the day, I would actually place this part down horizontal. Again, this would allow me to get the part down onto a surface as much as possible so that when I come in and machine it, I can actually use that to my advantage. Now, if your part is built proper, we could, of course, throw another joint on this side as he's already had built. Again, we're going to go ahead and slide that in. And as you can see, this joint worked out very well. Yes, I probably should have put it underneath because you got the dovetail cutting into the stuff. Okay? So let's go ahead and throw a third joint on our part. Now, what I'm going to do is I'm going to use this surface on the backside, I think is going to work best. Now, what way you put this in your stock is going to be up to you, of course. But what I'm really looking for is that mindset of how can I machine this in here and actually put it on tab. So one thing you may see is it may not be wise to actually do this part upside down this way, right? So what I'm going to do is I'm actually going to flip the part and let's pull it back the other way and see if we can't get this about as far down and about as far flat as I would like. So again, looks like we're here at the top. We're actually going to say minus 0.02 so we can skim that nicely. Now, we do have this lovely little leg over here to the left, so I might actually slide my part over and get it off of my vise, because in my brain, what I'm going to do is I'm going to use this entire lower edge of my part as a tab in some function. So with that tab to my advantage, I'm going to use that to stabilize and keep my part up, do all of my finishing stuff, and then do something like a swerf and follow that bottom edge, right? So from this, let's get our stock out of the way. I am going to, again, take a quick peek at something because I think we're going to be able to do what I want to do, which is take his part, do a little Hollywood magic here. We're going to do a copy, paste new. Now, the reason why I'm doing a paste new, if you guys didn't know, is because these are components. So they are going to be linked together if you just do a copy and paste. So this is going to be extended. And then what I'm going to do is we're going to see what we can get away with on the old world of push-pull, right? So let's grab this lower couple of circles. Like, what is going on with that surface? Like that surface. You might actually have to remove that surface. Nope, I think we're going to be good. So all I'm looking to do is I'm creating a model to use later that is going to, oh, we will have to remove that surface. In there, highlight it, hit delete. Beautiful. And then another surface, we're going to go ahead and hit delete. So now I've actually flattened out the whole bottom of the model. Again, not a big deal because what I'm really doing is just creating something in the background for me to use later on. Again, we got a couple of delete spaces in here. Try this one more time. If not, we might have to go to the old school way, which is going to be the good old-fashioned surface way. There we go. So what I wanted here is my part. I'm going to go ahead and turn down this opacity. And then I want my original part, right? So when I start to machine into this, from time to time, you're going to see me add a model in, and I'm going to use that secondary model to make sure that I'm not machining all the way through that part or past those tabs. Now, one thing I do like, and this was something that actually shocked me, like you guys always surprise me with fun stuff like this, but if you notice, he actually set his stock up, and his stock itself physical. Is it physical or is it here? The actual physical material. Give it a sec here. I believe he set it in such a way that it's almost like glass. Maybe it's an appearance. Is it an appearance? I believe it's an appearance right here. So by creating the physical material to be aluminum or steel or whatever you're doing works great at the end of the day if you were to create setup sheets and other things, right? But his appearance, he made it out of glass so that you could see through it literally like it's a window. I love this. This is a great way to do it versus the way I think a lot of you guys just saw me do. I went in and I used the opacity setting to turn down the opacity, right? So keep that in mind. You guys always learn something new. You guys always teach me something, right? So let's get into machining this. So I'm going to go ahead and switch back to manufacturer. I think for the sake of this part, you know what? I think we're going to get away with reusing that setup for sure. I want to make sure that we're only doing the master model, of course. Again, my jig and fixture hasn't changed. If I was going to put this on a machine, yeah, let's throw this on a machine here. We got a Haas. I don't have a V UMC in here somewhere, or do I got to download it? Sometimes it's there, sometimes it's not, right? All right. So what we're going to do is we're going to go ahead. I believe he is using a UMC. We're going to put this on a UMC 750. Of course, it's going to ask us that famous question that we need to download. Sure, we'll download it. Stick it right in that free support folder for me to delete later. Seems like you guys quieted down in chat. You guys doing all right over there? I'm moving too fast for you. So again, as you guys can see, some poor individual went ahead and put that machine on. That's going to drive me absolutely crazy because the entire basin enclosure is turned on. As you guys will notice, is I always turn that off when I build machine systems for most people, because you're not worried about your part hitting the outside enclosure, right? You're more worried about spindle contact and things like that. But let's do some toolpaths now. So what I'm going to do is we're going to go in, and because I did put that giant flat up top, I think we could do this part with a face mill. And we'll go with that good old-fashioned 2-inch face mill. And we're going to just let that do what it does best. And now we can start to go in and do our adaptive clearing type stuff. Now, up to you which way you would want to do adaptive clearing to start. And I am going to edit this tool before we grab it again. Reason for that is I'm probably going to need a little more length below the holder. I'm going to go ahead and bump up that length and that shoulder length. So 1.25, that'll give us a little better end mill to work with. Let's accept that. And now, roughing it from the top down, I think the advantage here is that we're going to be able to clear out a ton of material around this, still keeping as much rigidity as possible, but then we can quickly go in and finish our outside walls, right? So I am going to go ahead and turn on shaft and holder as well. We could either auto trim. So again, if you guys didn't know this, we could do detect tool length. We could pull away. Again, keeping that tool from hitting our part or our jig or our fixture, right? Let's go ahead and give that a second here. And I'm getting a lovely roughing strategy. I'm going to go ahead and hit F8, and then I'm going to hit F7. As you guys can see, I've now roughed that part working downwards. Again, gotten everything out that I wanted, and I've actually machined down quite a bit. Still avoiding my jig and my fixture, so I might need to make a couple of changes to make sure that we're not causing any problems there. But I think I can work with this. So, as we talked about, maybe you come in, 2D contour, right, guys? We're going to go ahead and hold the Alt key. I'm going to 2D contour around this bottom edge. Maybe you're going to do multiple depths, things like that, right? I think we can get this end here, and I'm going to leave that end alone. Again, you could extend these out. Of course, we could trim that even more. Get that toolpath turned back on. As you can notice, we're actually clearing everything. This is the importance of having your model and everything set up inside of Fusion. But that gives you a nice finishing pass. Yes, multiple depths, blah, 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 guys. I get it. Again, we are dealing with a radius to vertical walls. Maybe I want to just 3D mill these. A lot of options inside of Fusion, right, guys? We could easily go for like a blend strategy, swap out to a ball end mill. So let's go ahead and grab our 1/2-inch ball. I'm going to go ahead and select our drive surface, which is all of this. I'm now going to go back and add my drive curves, right? Oh, let's go ahead and close that. I feel like I always forget how drive curves work. So when this thing fails, I'm going to assume it's not up the walls, it's along the walls. And let's see what we get. So went ahead and failed that toolpath. And I'm going to go back and recommend that it's probably the drive chain. So let's go ahead and give this a single chain. Doing some thinking, putting in some work. I don't hear the fans kicking on yet. I always love it when you guys jump in here. So quiet, just watching me program a part. Again, that's taking a little longer than I like. So again, I'm going to probably change things up. So let's go for a different toolpath while we wait on that one. Again, maybe we'll just do a simple contour toolpath. Selected boundary. Down and around. Back up. and back the other way. We need to extend that out a little bit. I'd have to restart our selection process. Go. Get that to come down and around, back up. But we're going to go ahead and just let it go around that whole way. Right? Again, you can adjust our step downs. We have our tool on center. I'm going to turn on contact point boundary. What that's going to allow me to do is to wrap down and around that surface. So let's see what we got from blend. We actually got a really good tool path out of blend as well. It took a little bit longer, but as you can see, it still got us a very, 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 very good tool path, right? You see a defect here. So I think, let's go ahead and check something. I think my contour took off a little bit of a different way, or my part actually might not be sitting inside of our stock. Let's go ahead and check that first. Where is my stock? Yep. So even the best of the best, we all make mistakes, right, guys? So as you can see, I'm going to have to go ahead and shift when we did that part inside there with that joint. Again, this is the absolute luxury of working with true models and everything in real time. Again, is I'm going to comp this forward 20. Again, let's see if that is fully inside. Nope, we're going to have to go probably closer to 50. There we go. So again, we go back to manufacture, of course, and now we hit regenerate on everything. You guys get to hear me ramble on, and maybe this will be a good point for me to get you guys with the sales pitch and everything. What time do we got here? Oh, it's only 51, right? We still got a little bit of time before I get you guys with the sales pitch. So the difference between blend and flow, that's actually a really good question. So as you guys will see is I did blend up here. And when we look at the actual blend and what it says, blend is a finishing strategy for machining surfaces that are between two curves, right? So like your fillets is probably one of the best things to use. Now, if you're looking at using more of the flow toolpath, this flow toolpath isn't terrible, but the problem really starts to reside in the fact that when we do a flow toolpath, again, it's looking for drive surfaces, right? If I select all these drive surfaces, kind of the same as I did the other. Now, what's going to happen is I have the ability to set a long U or a long V, right? So when I say okay, what you're going to notice is it's still going to set that toolpath in a fixed direction. As you can see, we're running up that surface. Now, if I wanted to run along that surface, again, we'll say a long V now. We should be running horizontally across our part. Again, ignore the whole step over, step down scenario, guys. But you can still get a very similar toolpath between those two. Now, what I've seen a lot of times when people are using flow, they tend to run into issues when your surfaces start to change like vertical directions and things like that. Now, I don't think ever is there a wrong or a right? So if we came in here and we set our step over as actually like 20, and then I'm going to check in on our blend strategy. Our blend strategy is using a step over of 20 as well, right? So as you can see, both of them very much accomplished the task of going down and around the part, and both of them are blending that upper surface to the other. This is actually a good example of what's happening, right? So when we look at blend, notice how it comes around the surface, right? So when you're using flow, what it's getting to is it's getting to a point where it's realizing and it's thinking that it needs more step downs in this area. So it's actually stopping and feeding up. So it's not a blend between two curves. It's just trying to flow and follow those surfaces, right? Devin, awesome. I love it, man. Appreciate you watching our content. So again, now we're going to go back. I'm going to go ahead and remove flow. Again, we have that terrible contour strategy as well, so we don't need that. Let's just hang out and use blend, right? Now, from here, what I'm going to do is we can start to finish into our part. So again, I'm going to steal the adaptive clearing that we've already done. Good old-fashioned copy and paste. And now I'm going to set my tool orientation. So again, we're going to go tool orientation. I need a Z direction. I'm going to go off the floor here because I think overall that's pretty straight to the bottom. X-axis on the UMC won't actually matter. Now, this is where I may need to add in model. And now I say I may because I want to see what I get first. Intentionally probably going to get some problems here, but I want that so that you guys can see how this is going to affect it by using model, right? So again, we're going to give this some time to think about what it wants to do. And with that, guys, if you have any questions at any time, feel free to go ahead and send us a ticket in the support area down below. If you have my email, you can also send in parts at any time as well. Oh, there we go. Let's get my drink turned around here. This thing is really having to work for it with the rest machining. So in the meantime, let's go ahead and throw another toolpath at this. I'm going to change gears real quick to the actual, whatchamacallit, pocket clearing instead. Same surface. Again, we have our rest machining turned on. And you know what? I do know what the problem is. Let's go ahead and check a few things. So we are from remaining stock. Okay, cool. So we are starting to get results now. That's good. Got to rethink about what it does. Let's get pocket clearing out of here real quick. How's everybody's week so far? Pretty good week? Good time? Another trick so you guys know on these adaptive clearing toolpaths, the problem why it's taking so long is the settings inside of here. As you can see, we have like our 100% step down, 10%, and then usually it takes you out to 1% for fine step downs. So by increasing certain areas, let's say, for example, I'm going to actually go 125 down. I'm going to fine step down maybe like a 1/4 inch, and then I only want to get within 10 of what I'm doing. It will dramatically change how that toolpath goes. Now, I'm going to hit cancel because we did get a toolpath, and we are getting something that I wanted to show you guys, right? So as you can see, we currently have fixture avoidance, so that tool is not hitting our fixture in any way, but we are starting to cut under our part, right? And this is a big deal here because we wanted to use that part as much rigidity as possible, right? So this is where we use that model setting, right? So again, is what I'm going to do. You guys didn't know pocket clearing calculates way faster. The strategy you all end up picking is going to be on you. So what I'm going to do is I'm going to turn on model now. I'm going to add in the extended model for what I want to machine. Again, we don't need a boundary in this case. And we're going to go ahead and hit, oh, we got to swap our tool out. That was probably also why adaptive clearing was getting a little wild on it. FHN mill, orientation this way, no boundary. Obviously, looking at all of our previous things that we've done, we're adding an additional model. And from that, let's see what we get. Again, the whole idea here is we want to not machine underneath that edge right there. So as you guys are seeing, yes, we are machining some of this stock off the end. It's not the biggest deal in the world. We could, of course, fix and adjust quite a bit, right? So as you can see, we're still maintaining that stock. It's a little tricky to see to hold our part in the air so that we're not breaking it away from everything. So again, inside our part, though, we may need to add additional surfaces. But this is, again, this is why I love Fusion 360, guys, is the ability to quickly go in, try to do something, and then realize, like, on this specific part, right? This is our master part, so we're going to go ahead and move everything out of the way. Now, I am going to use the stock bottom here to create another surface, right? So this is kind of cool when you could say, oh, you know what? I actually want to create a new body that is going to join to that other body, right? So again, what I'm going for is creating what I want to machine off. So I just highlighted that surface and I hit delete. Again, I can go ahead and change this up as much as I want. So what I'm going to do is we're going to do a little bit more push-pull here just to give it a nice clean surface all the way down. Again, another thing you may be able to do on these surfaces is the ability to go in and hit delete. And upon hitting delete, notice how it pulls it down automatically and sets it where I want it, right? So this is the idea of how we could actually use this to our advantage. Again, when we go back to our manufacturer side and machine out that part, right? So again, we're going to go ahead and hit F8. Oh, F8 is going to turn on stock. F6 is going to realign us to our part. Get in here real quick. There's our part, there's our jig, and there's our fixtures. Again, we have our roughing cycle getting all the way down to where we're doing our pocket toolpath. Again, upon regenerating, because we have that additional model in place, notice how we're only machining so low on that part, right? We're not coming down and around anymore or dealing with any of that. So I don't want to bore you guys to death with all these additional toolpaths to get there, but basically what everybody's probably wondering is once we finish out the entire inside of this part and all of that is how can we actually split it off, right? So again, the idea is to use something like a advanced swerf toolpath. And what I'm going to do is let's start by cleaning up the upper edge of this part, right? So if I want it to come up, over, and around, went ahead and picked my drive surfaces. So we're going to go ahead and see what we get right off the start and see what kind of changes we need to make. Now, this is a very strange and tight corner here. So this end mill is a little bit large in there, but with that 3 surface selection, I actually very quickly created that toolpath. So again, if we went back and went to a smaller tool, of course, go ahead and do I have anything smaller out there? I should have a 1/4 inch in here somewhere. That's a 1 inch. And we could always go to the Fusion library, right? So extra flat. Here's down to a 1/4 inch end mill. Same toolpath. Again, it broke it up a little bit just because we're trying to get up and around in these tight areas. My tool does not, it's got holder detection, right? So again, bad holder on the tool. Again, we have shoulder shaft holder detection. If I was to edit this tool, swap out the holder. Let's see what we have for a good holder. What do we want to go with? PR16. Let's see what that looks like. Much better. A lot more clearance on that tool. Again, we regenerate. And we'll get more of a tool path. Again, it's starting to clean up. I think we're still having a problem because as we come around, the way that tool wants to actually lean and tilt its way around, that is, again, settings that you guys have full manipulation over. So things like your automatic synchronization mode, things like that will change all the distance, right? So again, you could do a shortest distance. And as you can see now, that tool path, one clean swipe up and around our part. So I would reuse the same tool path. So what I'm going to do is I'm going to push Control D to duplicate. And then again, with that duplicated tool path, I'm going to change what surfaces I'm using, right? So again, using this lower floor surface now. Again, we go ahead and hit OK. Now, right off the rip, my tool is completely pointed the wrong direction. So let's get the tool pointed outwards, not inwards. I'm going to say flip tool. And now, again, you can see I'm running down and around the outside of the part for that swerve toolpath, right? So what that would look like on the machine, we're going to go ahead and turn this on. What we're seeing here, clearance egg. So this is something with this machine right now. We may have to actually go in and fix that, of course, but what we're looking for is just an example of what that toolpath is doing, right? So again, we're coming down and around. So our again, Fusion collision detections are telling us that we're having a collision here. I did not rough the part out enough. This is on me, guys. But we can come around and we can cut that part off, as you can see with that end mill, right? So again, continuing down and around a little bit more, and that would basically break that part away. Now, one neat thing that would be great for Autodesk to add to some of these things is things like tabs right here inside of this toolpath, right? It would be cool if this was like 2D contour if you wanted to add tabs. Now, we can model those tabs. As you guys saw, it's not very difficult to add certain things for models, of course, and avoid those areas. But as you all may want to do is you may actually want to go in, cut around it. We, of course, want to go past the bottom, like 0.1. Again, so that that thing snaps off as clean as possible. So I'm not seeing a bunch of questions come in, which kind of worries me. You guys are either speechless at the part that I'm making, or you all know it's time for me to hit you with the old how to support my channel, right? So guys, I appreciate all of you. I appreciate the stuff you send in, the questions you guys always have. You can support our channel in a lot of ways, from something as simple as liking, subscribing to our channel, and sharing our content, to as simple enough buying me beers. As you guys have noticed, I do enjoy my beers. It makes this content a lot more fun, and I look forward to it on a Friday. But you could also use jitcadcam as your Autodesk reseller if you're in North America. We sell and support Fusion. It is 30% off right now if you're looking to add a commercial seat. Feel free to reach out to us at any time. We're here for you. So, what are we thinking, guys? I see a lot of you quiet in the old chat. You guys came in with that heat and then you kind of slowed down. Maybe I should check in on my surprise on my other screen. That is. Let's see. Give me one sec. All right, doesn't look like it's quite there yet. Anybody have any questions at all? Or is it that break time? Is it time for everybody to go grab a coffee and come back? See what we can come up? Still watching from the treadmill. I like it. Evan seems like a good time. How to make a 5-axis machine doesn't go home position while orientating apart. For example, the Haas UMC 750. So that is going to be a little tricky, but you're going to have to do something like that inside of your post processor, because what is going to happen by default is, my question would be, is first off, it's going to go to Z home when you do things like that. So if I go ahead and hit post process, is down here at safe retracts, you do have a force XY on indexing. Now, keep in mind, you also have a safe retract setting as well. So if I wanted to, I could actually use G53 versus clearance height. And that was the error that we got earlier when I tried to machine sim this. Let's go ahead and change that back to G53. And let's redo that machine simulation. So give this a second here. Unsupported safe position method. There we go. Advanced swerve. So our unsupported safe position is also now causing a problem. But the idea is instead of going all the way, as he's saying, is on your indexing XYZ home, you do have that ability to toggle that in the post. You also have the ability to use a different home position. But one big thing is I've seen a lot of people ask about clearance geometry. And I think I'm going to finally do some videos on this for a Workflow Wednesday. But you could set a custom clearance as well, right? So one thing I could do is I could say a sphere, and then I could select a point for something like the sphere clearance. And then with that, I can actually set a diameter. Now, I'm going to do this pretty generically so that you guys can see the results of this. But as you're looking at on this part, not ideal. What that is creating for me is a physical sphere that is going to be now my clearance for all my toolpaths. So if I wanted to change gears here, let's say I want to do a cylinder based on an axis, right? So we're going to go ahead and select a direction, and then my direction point. And then again, I can do a diameter or radius, of course. And what you're going to get now is exactly that, right? So a diameter that tool will clearance when doing a toolpath. So what you're going to see is our lovely advanced swerve needs to have linking moves turned on. But as you're seeing, that tool is now clearancing out to where that cylinder was before coming in and machining against our part. So based on situations like that, you do have that ability to set custom clearance heights on those 5-axis toolpaths. Now, something else that you could do, and I don't know if people have ever recognized this, is you can actually come in, and when you look under the Modify tab, there's now the ability to do lead and linking, right? So you can modify your leads and links based on what you want. So that's the great thing about working with somebody like myself over here at jitcadcam. We can actually modify your post so that it works with basically anything and everything. So again, is based on how you want to set it up or what you're working with. Of course, we can make it so that when it does index, that you're only going to, right? Questions outside of that? I see a couple other questions come in. Looks like there's a little bit of a problem with this post processor. Go ahead and reset that to default, and that is causing our rewind. Good old rewind. You guys love that code, I bet. Always get the old rewind code. Go ahead and fix that. Ash, you finally made it, man. We did your whole part. You're about an hour late. There we go. And if we tried to machine simulate this, I think we're still going to get this error because it keeps trying to default, yep, the safe position method. Got stuck at work. All right, let's do this one more time. Post-process. So what you guys are seeing on my end is Fusion is hung up on the safe retract. And it's, for some reason, this post-processor is getting pulled directly from the cloud. So for this part in particular, what I'm going to need to do is I'm either going to need to copy that post over, which is what I'm going to end up doing, or setting it to another post that I may have laying around. So let's go ahead and go to the inspection post. Again, as you can see, we still have our XY. We're going to turn off force XY on indexing. Now we get good G code, of course, but I do need to fix that at the machine level as well. So I'm going to redirect what post we use so that it stops hanging up on that error. I'm going to go ahead and jump back over. We have these lovely posts in here that Fusion Phil himself has completely butchered for your guys' views. And let's put our simulation moves in there. One more time. Let's go ahead and try that simulate with machine. And maybe this time it'll work. I think she's going to work. She's thinking about it. There we go. So again, based on this toolpath, we now have all of our linking moves here live as well. Again, I'll let that run out a little bit. I see a few other questions come through. So again, we're roughing out that part as we discussed. Looks like a little later in our program, we're going to actually hit something which we were aware of, which is our machine is now causing collisions against other parts, or our tool holder in this case, hitting our actual vise. So again, great thing about simulation, guys, just saved you a $15,000 spindle and 2 weeks of downtime. What I'm really looking for is, let's go ahead and jump to our swerve. Again, you're seeing us come down and around. We are doing a full retract in Z, as somebody was asking. But if you notice, in simulation, we're jumping immediately down to that next point, right? While still running around our part. Again, there's our another swerve toolpath, around and out. So I did see a question. What does the thin wall function inside 2D Contour do? Let's go ahead and find out. Let's go ahead and jump back. We're going to go ahead and look at that thin wall function. So if I remember correctly, where is it here? I believe it is in multiple depths. Could be wrong. So what thin wall is going to do by default? So it is something that can reduce vibrations at the end of the day. But what it's going to do is, excuse me, guys, is it's going to change dimensional accuracy based off what's going on to help with the surface finish. A lot of times you're not going to notice a difference. And I always tell people, if you're curious about something, the easiest way to see if there is a difference, take your original toolpath, duplicate it, and then let's go in and turn it off. Right? So again, we're going to use thin wall, and now you have thin wall width, and this is going to control when it's going to change its strategy and things of that. So as you can see, looking at our toolpath from the data level, we started to do step downs, but again, this doesn't have thin walls on it for that particular purpose in machining. So Kristinell, looks like you had a question about the machine and the post in the cloud. Yes. So when I initially grabbed this machine, just so you know, is I'm going to pull up my actual library, is you have your own cloud storage area. I usually recommend that if I need a machine, you guys copy that machine over to your cloud so that it's not linked still. Because if an update hits and causes a problem, or as you're seeing that post is giving me a little bit of issues, is being able to copy that machine over and then utilize it, right? So right now, I have this machine right here. If I wanted to, I could copy, go to my Haas area in this case, paste that machine, and now I have that machine to work off. Same thing with the actual post processor. Again, In my case, I put some of this stuff local because I know I'm going to delete it later, but I would do the same thing, right? So if I go to milling, look at my Haas machine, and then with that, whatever post you're going to grab, I'm going to grab the inspection post. And then I would stick that, of course, in my cloud area. So as you can see, I'm going to go ahead and paste that in there. I now have that Haas inspection post. So that's the one I want to use. And what you're going to notice is now it's disconnected it from the cloud to update. It should keep it much easier for you at the end of the day. Awesome. Best idea to align vice / item on the machine. Mateus, are you talking about putting this vice on the, like, physically on the machine? So usually in the world of something like this UMC, you're going to have some type of alignment lug, and that is what's going to put it on there. Now, for my guys out there that are doing a 4th axis, or actually a 5th axis on like a vertical mill, or like a TRT 210 or something, what I have a tendency to do, I'm trying to think of the best way to show you guys, is I will have them tell me where that location is. Let me see if I can find you guys. Yeah, I don't think this is going to be it. Nope, this is a 5-axis. Might have to. This gives you a good idea. So on a 5-axis machine, you have this center lug, which is pretty true. So usually when you are setting up and using something like a part like this or a 5th axis vise, a riser, it's going to auto align it to where it sits. Now, as Mateus is saying, this is a little different scenario where, I'm trying to think if I could show this. I think I can show this on this part. So he's saying his vise isn't perfectly on center. So what I might actually do when I do my part positioning, right, is I can go off a stock box point. So presumably, he's probably probed top center of his part, right? And now you will need to have probed the table somewhere. But as you guys can see, is I can determine the distance from that actual center of location on that table. So what you're seeing me do is, if I go in and I probe the center on that table, top of the table at like 59, right? And then I probe the top of my stock in 54, and I just do the math between the two, I can then pick up, shift, and compensate, and basically place that stock on that machine wherever I need it, right? So now in this case, my part should be true to the world when it comes to that simulation, right? So again, as if I simulate this, give it a sec here to load and get rid of this base that you should always turn off. But as you guys can see, now my part isn't setting true on machine. So again, is when we come in and start to do our toolpaths, you're going to notice it's going to jump down and around, get a little further down in the process. And now, again, we're machining off center, right? So it's no longer perfectly aligned. Yep. So, and yeah, so if you're using a tombstone, that's a great way to do it, right? So based on where your part lies out in space, another way that I've personally done it that works is, as you guys saw, I was very easily to do that from the stock, right? But now when you get into 2nd, 3rd op type setups, it's a little trickier. So I prefer in the design workspace, and this is a great part that Ash gave us, is I tend to do it with a joint origin instead. So again, as if I go from like top center of this area, again, I can put that joint origin wherever I need it. And then I can use that joint origin the same exact way, right? So there's my joint origin versus my part. Manufacture workspace. Again, we go back and edit our setup. Now, instead, I would use a selected point. And that selected point is going to be that joint origin. So I may need to make sure that that's turned on. So it should have thrown it under stock more than likely. It did. So let's get our stock turned on. But now I can select that joint origin and then the attachment point. And then in this case, you would leave everything still zeroed out, right? As you see here, is it's now brought everything down onto my table based on those positions. Again, little different way to do it. Yes, these are huge numbers, but yeah, all you're trying to do is replicate from a fixed point to the where the stock lies on the machine. Again, I'm trying to think here. Actually, we can show you guys some pretty cool stuff now if I can remember. Which one is a machine? Give me 1 sec here. I'm going to go ahead and jump over to my other screen. And then with that, let me go look at some old. I'm trying to remember. I know at one point I did do. Yeah, it's not going to be in here. I did place a TRT 10 for a customer. Yep, that's a UMC. But what we did is, to explain it to you guys, is once they got their 5th axis on their machine, we just probed center of where that rotary was. And then when I modeled the machine sim, we just went ahead and placed that basically as close to perfect to match the, right? So again, giving them plenty of room for their vise or anything else. Any other questions? Oh, we got Tomahawk CNC in here. Finally up early enough to jump in on live. Tomahawk, where are you located at? Any other questions in the meantime? Tony, I did just see your email come in. I need to close some stuff out here. Tony, I got your post processor and everything. I will be taking a look at that later today. So I got a question about the flow tool path versus, again, we kind of talked about the flow path a little earlier with overlap instead of number of step overs. Let's take a look. So if we go ahead and pull up that flow tool path again. Maybe I am crazy, but I am still seeing based on step over. I would need to know now defined with overlap instead of number of step overs. Oh, I know it. So, all right. I think I know what you're saying, but yeah, it's based on step overs flow. Are you sure you're not thinking of, what's the other toolpath? There is another toolpath in 3D, and I'm trying to remember what it is off the top of my head, where it's defined by the number of passes you want to make. And I'm drawing a blank, guys. Drawing a blank. Was it Flow a year ago? I feel like I remember that. I feel like there's just so much stuff that changes. It's hard to narrow it down, because like in the pencil toolpath, you're still, yeah, the pencil toolpath is based on number of step overs. I am correct in thinking there's still a path out there, but I think you're right. Somebody prove me wrong. I think you're right. I don't know why they changed it. Again, in my opinion, as we've seen other toolpaths come out, I've pivoted my style of programming where I almost look at flow personally, because of the way it's defined, is it is a step over path. And as we said last week, like if something is saying step over, it's for shallow surfaces versus steep surfaces. When I think of a fillet here, again, a fillet in this case, that blending of that fillet isn't really a step over. It could be at the top, but then once you get to the bottom, you get too steep, and there's all these other kinds of problems that happen. Again, it's kind of funny because blend, it's also step over. But what's really weird with blend is I think it's driving it more based on creating that even cup height, right? Because if you got down here and your step over was dramatically different, which we did see. Do I still have that flow path on here? I don't think it changed really how that toolpath interacts with that, right? How does tool orientation in the 5-axis tab work? That's a pretty good question. It actually works the exact same way as when you do your setup on your part. So I think a lot of people overthink things in Fusion, but when you create your WCS in Fusion, the first thing I always teach people is don't pay attention to the world coordinates, right? Like world coordinates, that's a master cam thing. That's the way a lot of people are thinking, is like my part in this case is orientated the exact same way here. With that being said, is when I go into my tool orientation, if I need a tool orientation, of course, is I can turn on that orientation and then I can define it the exact same way, right? So if I wanted to define it pointing this way, I can use surfaces and edges to set that to a fixed location. Now, I call it the pirate wheels, but I can also twist and turn to get that Z orientation as well if needed. Now, in the world of 5-axis, a lot of times you can use tool orientation and set things like your actual multi-axis control, as well as how a tool is going to tilt and lean and things of that nature, right? So in the case of Swerf, you're not going to get a lot out of it, but if we were to go back and look at something more like geodesic, full 5-axis, now we have our primary mode from vertical. Well, vertical is going to be defined by based on which way are we pointing, basically that Z axis, right? So now it's vertical from setup Z, or is it from tool orientation Z? So again, when you get into the full 5-axis workflows of Fusion, we're filtering things down further and further, right? So as you can see here, how do I want that tool to tilt? When do I want it to start tilting? All based on coming from a certain direction, right? So again, it's things like tool axis limits, override tilt angles, again, can all be driven from a tool tilt or a tool orientation. Australia, awesome. Love to hear it. For those of you guys that don't know out there, you know there's more people in California than there is in all of Australia. It's pretty wild. Makes me feel like North Dakota. What is the idea? Christinelle, I believe you're referring to that same question about the 5-axis, correct? Tool orientation, the ability to set in direction based on which way that tool is going to come from, or how you're going to control tilt from tool orientation. Talk about 4 and 5-axis. Cool, guys. Any other questions from anybody out there? I know we haven't had a lot of people in here all at one shot, but what's really crazy is the amount of people that have actually viewed this video. So it looks like a ton of you, all 116 of you coming and going throughout here. And we appreciate each and every one of you. Let me pull up a few things here. Make sure we ain't got any tickets coming in. And let's if my other righty, let's go and look at something. I show you guys my surprise. I might have to make a phone call here. See what is going on if I'm allowed to show you guys. Don't think so. Let me try something. If any of you are saying anything in chat right now, just know I can't see chat, so I apologize. It doesn't look like it's quite there. All right, we might have to hold off on the surprise until next week. Is it possible to face apart with a 2D adaptive? You have a fully open pocket from all sides. So that is an amazing question. And I would say yes, but also no. So the problem you're going to have, as the question entails, is when using a 2D toolpath, here's a perfect part, is he is asking whether or not you could use 2D adaptive clearing to rough off the top of this part, right? So what I'm going to do is I'm going to hit OK. And what you're going to notice is I'm getting a, hey, you haven't given this an edge or a pocket to work off of. So I would have to give it a boundary, right? So what you're going to notice is if I give it this boundary, it only goes to that boundary, or it works inside outwards to that boundary. So using 2D isn't going to achieve what you're asking of it. But what you've already put in chat, and I appreciate, is the ability to use 3D adaptive would be the way to go. Now, a couple of tricks with something like this, though, are, one, we want to machine from stock top to highest again. And then what we want to do is we want to go to model top, right? So what I'm doing is I'm filtering Z with an adaptive clearing toolpath. So give me a sec, guys. I got to drag this back to the top. And I will have to check my setup, but okay. So as you can see, we are now going in and starting to do something. So let's fix this because I think what's happening, almost certain I know what's happening, is when we created that stock, let's go fix sized. Again, somebody out there sent me quite the part. But what I can do is do exactly like you're asking, but I can filter it and then utilize that for a later use. So again, in my opinion, the great thing is you can do that with a 3D, which is model aware, right? We're doing model aware stuff. And with that model aware, as you can see, it makes it very easy to go in and create that toolpath to rough out that part. Now, I did do a really good tool or a video a while back. I think it's called to face or not to face, where some of the other strategies might actually work out very well also, right? So this is where you could do something with like spiral or morph spiral tends to help out as well. If you're somebody that's ever had to rough something out, you get like weird islands and the piece chunks off and flings through your machine, right? Cool. Guys, do you have any other questions for me? Gotta shoot a text message over to see what's going on if I could show this surprise or not. I do not think I'm going to get to show it today. A little disappointing. Give me 1 sec here. Alrighty. Questions, guys. Anybody have any questions whatsoever? Go ahead and give you guys a few minutes. If you guys have any questions at all, I'm going to go ahead and clear up some of this stuff. Go ahead and save this. Thanks again for those of you that have been sending in models with all the questions. Makes this a lot easier to fill 2 hours of time versus me up here blabbing. That it? Everybody quieting down? Is that the go around? I feel like we could call this early this week. What do you guys think? Should we call it early? Should we hang out? Going once, going twice? No other questions? Give you guys a few more moments. I need to check on something else. Okay, good. I haven't seen it yet. All right. Let's see here. He just got a message back. Can a 2D pocket operation start from outside? Any other way than selecting none in geometry? So that is a pretty good question. Let's go ahead and completely ruin this part that was sent in. I believe one of you guys out there have made this part, put a lot of time into it. So what I'm going to do to this part is I'm going to make an open pocket to kind of show this. But the question is basically starting outside versus starting in. Okay. Oh, we got to get one of those sketches turned. Run into problems with selecting geometry. So if we had something with an open pocket like this, and we were to do a 2D pocket toolpath as it was asked, when I go into select the pocket, if I pick the floor, it's going to give me the hard edges of the walls of that pocket. So if this is an open pocket specifically, as you can see, again, by turning on now stock, when I go into machine this, what you're going to notice is it's going to start off the model automatically and then work its way in and rough that out, right? So again, some other things you could do is in your ramp settings, there is the ability to say plunge outside of stock. So if your part has pockets, but then also or closed pockets plus open pockets, anytime it can plunge outside of stock, of course, it's going to plunge and then work its way in. So with you asking those questions out there about the pockets in the stock, if you want to use the support email down below, feel free to send in that part and I can open it up here in real time and we could take a look at it all together. Go ahead and get some stuff closed out. Go. Ash Designs, guys. I think this week is sponsored to you by Ash Design. I'm pretty sure he might have just bought me a couple of 30 racks. He was the one that has provided this model for you guys, the bracket CNC model, that you guys could see some different ways to machine this and how to manipulate your boundaries. But it looks like he's also buying me quite a bit of beer. Ash, if you get a very terrible phone call from my wife, I'm pre-apologizing. Okay, yeah, we can take a look at 3D Pocket as well. Sure, let's go ahead and go do a 3D Pocket clearing. So again, what I'm going to do is I'm going to leave everything by default the way it is. Now, what I commonly see is basically what is being asked, right? Again, we have an open pocket, but what this toolpath is constantly trying to do is either profile or helix down in that open pocket. So if I wanted to start outside of the stock and work my way in, the first thing I need to do is I always tell people is we're going to look at this part XY, because if we go through our steps, we can see we have a tool. We're not doing multi-axis at the moment. But if I go to the geometry tab, what is happening by default is that bounding box machining boundary is the problem. So if you think of a hypothetical box right now on the outer profile of our part, and the tool is now set to only go to center, that's why it's still thinking that it's inside of a pocket, right? So we can change that. The first thing I would do is I would tell you guys, go ahead and flip that over to none, and let's hit OK, right? Now, without a boundary, right off the start, what you guys are seeing is it's now working from outside in, right? So this is very beneficial, as you can see on a toolpath like this, is we're still using 3D. And sometimes one thing that'll help you is 3D Pocket is a little behind. We should still actually turn on our stock contours. And the reason for that, before I make these changes, give me a quick sec, guys. We're going to actually make our stock much bigger. So let's go 120 by 120. Go hit OK. And then I'm going to regenerate these toolpaths here real fast. But I think what you're going to see is how beneficial that to and from kind of idea is, right? So from our stock, which our stock is much bigger now, right? And then where we're working to is to the model. So by increasing the stock, Fusion has automatically recognized that now this pocket toolpath needs to start much further out, right? So again, with that stock contour coming through automatically, or if you wanted to manipulate your own stock contour, let's say, for example, Ash, or not Ash, I apologize, you've actually machined the outside of this part. Well, in this case, I could give it this smaller stock boundary. And again, it will actually bring itself back in because it knows the difference between, right? So it is still thinking up here that this is machined off. Again, there's a lot of things we could ramble on about up here. We have rest machining, but we don't have facing cycle. Let's go real quick here, guys. We're going to go ahead and throw facing cycle, put the facing cycle before we actually do the other. And then what you're going to notice is now, because that facing cycle has done the upper part, it is now used rest machining to reach through and only limit that tool path to that open pocket, right? So in a 5-axis toolpath, is the tool limited to machine only the surface visible from the tool plane? It is not, actually. So we worked on a part, I don't know if I still have it. We were doing porting last week. And with that porting, let's go ahead and see. I want to say, yeah, it was 17. And then we did, oh man, what part was it? Did I save it? This is where yours truly gets in trouble here. There's the adapter. Give me a sec to get some of this stuff open up and see if we still have. Nope, was not that one. There's our machine. There's our rotary. Maybe it was this. Back to manufacture. And let's take a look here. Ignore. Yep. So this was one of the parts we were actually doing. And the part itself, let's get everything activated and pulled up here. So what you're seeing is this is a part that required going in and doing porting. So this actually allowed us, when we were talking, and in the case of this part last week, the 4th axis only machine, and we need to port down inside these runners. So what we did is we actually went in and we did a, not geodesic, but I think we were doing steep and shallow is what we found out works really good. Because in that steep and shallow toolpath, upon saying steep only, what is going to happen is you have what's called allow undercuts, right? So we can machine undercuts. And then with that, we would still have to define our boundaries and all of that, as you guys may or may not know. But now I think it's occurring to me that there was a few other toolpaths that we threw at this that worked out quite well. But at the end of the day, it still all came down to the same kind of thing, is a contour toolpath also. I'm just going to do this real quick. Tool orientation this way. And then if we did a selected boundary, it's not a big deal. We'll just pull that outside edge. Again, we did based on 4th axis. That 4th axis is going to be based on X because this is a 4th axis machine. And what that allowed our rotary to do, oh, here we go. Primary mode. And then we actually, again, I'm making this stuff real quick. We had to do from point or from curve. I do not have that curve in here. So this is where I would go back. Again, I'm trying to do this a little quick for everybody out there. Created a plane. Sketched on that plane, right? And then I gave it a line. Hold on, let's go back here. Yep. And now we could do our sketch plane. Here's my line. That toolpath. Now, if we go back in, again, we go to our 3D. We're going to do our steep and shallow. 4th axis only. Set up X. We are going to go from curve. This is our curve, right? And then we're going to set our geometry. In this case, I'm doing a selection. We're going to say retain inside of that actual box. And we may need tool orientation. So again, I'm going to tool orientate now with 4-axis machine. Keep only. And lastly, we're going to allow it to machine undercut, right? Let's give this a little bigger step down for the sake of this. Y'all don't go crazy. So it's not, so there's a lot of things going on, right? So with the 5-axis simultaneous toolpaths, Christinel, what you see is that full 5-axis control, because we did do this part with a full 5-axis multi-axis finishing strategy, right? So we went in and we said, okay, tool orientation here. I want to machine certain areas. I need to say walls. I need to pick a floor surface, and then so forth and so on, right? So we went all the way through this and drove this fully 5-axis start to finish, right? Again, let's go ahead and give this one. Did we have a little overkill, but I think it's going to work for the. So again, it's like full 5-axis machine. So the thing is as you're saying, when it comes to true 5-axis, a lot of these toolpaths, I guess you could say, is 3 to 5, but they all still are based on a 5-axis principle, right? So like, even if I went contour, I always create a toolpath based on 3, but the moment I go to 5, I have the ability to set, from curve or, automatic collision avoidance. Same thing as you just saw me doing multi-axis is, as you're seeing down here, tool axis mode, lead and contact. Again, it's more percentage driven at this level toolpath. And I got a lot of these more advanced toolpaths are coming from module work, right? Any other questions from anybody at this time? Going once, going twice. No? We're good? That's it? I'll start the outro and then you guys can tell me like always. Guys, it's not what you know, it's who you know. You guys all know Fusion Phil over here at jitcadcam. Every week we've been doing free support Friday for you guys, and we appreciate all the likes, the subscribes, obviously the comments that you guys leave, and the models you are providing. If you guys have any questions at any time, feel free to use the support email address down below. I will get back to you as soon as I can to help you with any problems you're having. As always, don't forget to hit like, follow, subscribe on this video, and if you feel that you learned something good out of this video, by all means, do not hesitate. Can't say that enough, to buy me a beer. Thanks, guys.